Hi, welcome back to MathWiz. In this video, we are going to solve 970129 paper 1-2 Feb March 2023. This is pure maths 1. Before starting to solve this paper, I would like to say after watching the video, please like, share and comment on the video. If you have not subscribed the channel yet, please hit the subscribe button. Thank you. So, okay, let's start solving the paper. Here is the first question. Okay, it says a line has equation y equal to 3x minus 2k and a curve has equation y equal to x square minus kx plus 2, where k is a constant. Show that the line and the curve meet for all values of k. So, what does it mean? We already are aware that for meeting at one point, b square minus 4ac must be equal to 0. And for meeting at more than one point, b square must be equal to, greater than 0. So, let's start solving. We have both equal to y. So, we'll write them equal. Okay. So, let me show the step here. X square minus kx plus 2 is equal to 3x minus 2k. Okay, this is also y, this is also y, and they are meeting, so they will be equal at that point. So we write them equal. Now we will bring all the terms on the left side and make right side equal to 0. So that we will get a quadratic. So let's write here x square. Now minus kx and 3x bringing this side, it becomes minus 3kx. So I'll write together, sorry. So minus 3x, okay, plus 2 and minus 2k bringing left side becomes plus 2k equal to 0. What we can arrange them. So x square minus x is common factor, so we can write k plus 3x, and here constant term we can write for c 2k plus 2 equal to 0. Now this is in ax square plus bx plus c equal to 0 form. Okay. So what is a here? A equal to 1, b equal to minus k plus 3 and c equal to 2k plus 2. Okay. Now we will find b square minus 4ac. So let's find b square minus 4ac, which is called determinant. So we'll write k plus 3 whole square. Why I removed minus sign? Because if you are squaring, it becomes positive. So we will ignore that sign here. Positive, no need to write plus sign. Okay. Now minus 4 into A is 1 into C is 2k plus 2. So this equal to, now let us expand the bracket, k square plus 6k plus 9. Now let us expand the other side bracket also. So minus 8k minus 8. Okay. So equal to k square. Now 6k minus 8k, we get minus 2k, and 9 minus 8, we get plus 1. And if you see, this is a perfect square. we can write k minus 1 whole square. Now, as this is a perfect square, this will always be greater than or equal to 0. It can never be negative. That means it can never be less than 0. So, whenever we get greater than equal to 0, that means it is going to meet for all the values of k. So, whenever you have this kind of question, you need to solve like this. So, we'll write here, hence, they meet for all values of k. All values of k. Okay. So, we are done with this question. I hope this is clear to you. Let's go to the next question. Next question is from function. A function f is defined by f(x) equal to x square minus 2x plus 5 for x belongs to all real numbers. A sequence of transformations is applied in the following order to graph of y equal to fx to give the graph of y equal to gx. So, stretch parallel to the x-axis with the scale factor half. Reflection in the y-axis. Stretch parallel to the y-axis with scale factor 3. Here 3 transformations have been applied on the function fx and then we are getting gx. So in that case, what will be the resultant function gx? That is what they are asking us to write. So let us do stepwise. It's a very simple question. Let us write gx. We are going to find gx equal to, first of all, fx. So we have x first, right? Now you see the first transformation. What is happening? Stretch parallel to the x-axis with scale factor half. In that case, what happens? Multiply by 2. The x will be multiplied with 2. This is the meaning. Now reflection in the y-axis. So reflection in the y-axis means that will be negative. So multiply with minus 1. So minus 2x, right? And this is our f of minus 2x. Now stretch parallel to the y-axis with scale factor 3. So this 3 will be here before f, means in that case for a stretch we multiply the function by the constant. So here scale factor is 3, so we are multiplying f by 3. So now we have to find 3f minus 2x. So we'll substitute in the function fx. So 3 as it is. Now wherever in this function here we have x, we'll put minus 2x. We'll replace with minus 2x. X square there. So let me write in the big bracket, square bracket. X, we will write here minus 2x square minus 2 into minus 2x, because x is minus 2x. We are replacing with minus 2x. Okay. Plus 5 as it is. Now let us simplify the bracket. We get negative 2 square is 4. 4x square. Now negative multiplied by negative. So we get plus 4x and plus 5 as it is. Then we get multiply out by 3. So 12x square plus 12x plus 15, and that this is our gx, and that's our answer. I hope this is clear to you. Okay, let's go to the next question. Question number 3. A curve has equation y equal to 1 by 60 times 3x plus 1 whole square, and a point is moving along the curve. Find the x coordinate of the point on the curve at which the x and y coordinates are increasing at the same rate. Increasing at the same rate means dx by dt and dy by dt are equal. So first of all, let us write y here, and we need to find dy by dx. So let me write y is equal to, we have 1 by 60 and 3x plus 1 whole square. So differentiate this with respect to x. So we get dy by dx is equal to 1 by 60 as it is. Now 2 comes here, then 3x plus 1 power was 2, to reduce by 1 that becomes power 1 only, so we don't need to write the power. Okay, now inside the bracket we have 3x plus 1, so we'll apply the chain rule, that for 3x it is 3. Okay, now let us simplify this. 1 by 60 into 6, 3 to a 6, and 3x plus 1 as it is. So we got 1 by 10 into 3x plus 1. I hope up till here clear. Next, we have to use the connected rates. So we know that dy by dt is equal to dy by dx into dx by dt. Now, we also can write dy by dx is equal to dy by dt divided by dx by dt. And as the question says both rates are equal, so we can cancel them. So we get dy by dx equal to 1. Now, what we have in the dy by dx, we have already defined. So 1 by 10, let us replace 1 by 10 times 3x plus 1 is equal to 1. So this gives us 3x plus 1 is equal to 10. This implies that 3x equal to 10 minus 1, that is 9. And then x comes 9 divided by 3, that is 3. So our answer is x equal to 3. Okay, let's go to the next question. Question number 4. The circumference round the trunk of a large tree is measured and found to be 5 meters. After 1 year, the circumference is measured again and found to be 5.02 meters. Given that the circumference is at yearly intervals from an arithmetic progression, find the circumference 20 years after the first measurement. So, as it says, follow the arithmetic progression, right? So, let us write the first term will be 5.00 meter. Okay, then comes 5.02, and so on. After 1 year, this. So second term is after 1 year. Third term will be after 2 years. Question is asking after 20 years. So after 20 years means we have to find the 21st term of this arithmetic progression. So let us to find the term, we particular term, we need A and D. So let us find A and D. So A equal to 5.00, D equal to 5.02 minus 5.00, that is 0.02. Okay. So now we know the formula. Tn equal to A plus n minus 1 into D. So we have to find T20, 20th term, 21st term. After 20 years, it becomes 21st term. 2021 equal to A is 5. So write 5 here plus N 21 minus 1 into D 0.02. So 5 plus 20 into 0.02, and that is equal to 5 plus 0.40, so 5.40 meter. That is your answer. Let's go to the next part. Given instead that the circumference at yearly intervals form a geometric progression. Now this time geometric. Find the circumference 20 years after the first measurement. Similar question, this time we have to apply the geometric progression. So we'll find A equal to 5, and so A equal to 5.00 or 5. R, we need R, so R equal to second term is 5.02, first term is 5.00. If you divide, we get 1.004. So this is our R. Now let us find T. As we know, Tn equal to A R to the power n minus 1. So T21 is equal to A. A is 5, R is 1.004, and power becomes n minus 1, 21 minus 1, that is 20. Now if you calculate this, we get 5.14, sorry, 41 5571 and so on. We'll write in 3SF, so 5.42 meter. So that is the answer. Question number 5. Points A 7, 12 and D lies on the circle with center -2, 5. The line AB has equation y equal to -2x plus 26. Find the coordinates of B. Here you can see in the diagram, center O is given, point A is here given 7, 12, and equation of the line AB, B is somewhere for which we have to find the coordinate, right? So to find the coordinate of B, what we have to do here, see, equation of the line already given, AB. Now, if we know the circle equation, we can solve them simultaneously. Okay. So, first of all, we are going to find the equation of the circle. Now, to find the equation of the circle, we need radius. To find radius, we have center and one point on the circle A, which is known. So, we can use this distance formula here to find the radius. So, let's find R equal to 7 minus 2 whole square plus 12 minus 5 whole square. Now we will simplify this. 7 minus 2, 7 plus 2, 9. 9 square is 81 plus 12 minus 5, 7. 7 square is 49. And if you simplify this, we get 130, square root 130. So we'll leave it like this. No need to calculate in decimal. This is not the perfect square. We'll leave it like this. Now we have to write the equation of the circle, and we know that equation of the circle is given by x minus a whole square plus y minus b whole square is equal to r square. So what is a and b? A and b are coordinates of center. A is here, b is here. Okay. So let's substitute the values. So we get x minus 2, that becomes x plus 2 plus y minus, so y minus b, so b value is 5, so y minus 5 whole square, and r value is root 130, so let me write 130, and we have to square this. Okay, so we get x plus 2 whole square plus y minus 5 whole square is equal to 130. Root will be removed. Now, see, we have already equation given here. Equation of the line AB. Y equal to 2x plus 26. So, we will substitute in this equation to get a quadratic equation in x so that we can solve for x. So, let's substitute. So, before that, we can expand the bracket. X square plus 4x plus 4 plus y is 2x plus 26 y is minus 26, sorry, minus 2x plus 26, minus 2x plus 26 minus 5 square equal to 130. Next step, copy down x square plus 4x plus 4 as it is. Now this gives us minus 2x plus 21 square equal to 0. Now we'll expand the second bracket also. X square plus 4x plus 4 plus, now minus 2x square is 4x square positive. Then we get minus 84x and 21 square is 441. So plus 441. Okay, I made one mistake here. It's not 0, it's 130. So that is equal to 130. Let us write now. What we get? If we simplify this, we get 5x square, combining the like terms, minus 80x plus 445 equal to 130. Now bring 130 to the left. So 5x square minus 80x plus 315 equal to 0. So we got a quadratic equation, 5x square minus 80x plus 315 equal to 0. Now we can simplify it further by dividing all the terms by 5. So we get x square minus 16x plus 63 equal to 0. What I did here, we divided all the terms by 5. Okay. Now we can factorize this. So we get, if we factorize, we get x minus 7 into x minus 9, and that is equal to 0. So x minus 7 equal to 0, or x minus 9 equal to 0. So this gives us x equal to 7, which point we already have here as a. So no need to find y for this because 7 and 12 already a. Or we can find here a. So y will be 12. Now here we got x equal to 9. So y equal to, we are getting 8 by substituting in the equation of the line here. Minus 2x plus 26. If you are substituting x equal to 9 there, we get 8. So coordinate of B, we need to mention here clearly. Coordinates of B is equal to 9, 8. That's our answer. Okay. Let's go to the next question. Now, in this question, in the expansion of x by a plus a by x square to the power 7, it is given that the coefficient of x power 4 divided by the coefficient of x is equal to 3. So, here, this is the ratio given here. So, we need to find term in x4 and term in x, so that we can take their coefficient and compare, and that will be writing equal to 3. Okay, this is the whole procedure. Now let us do. So we'll be first writing term in x4. So let me write term in x4, and we know, we have seen the binomial expansion formula. there for each term there are three parts. One is NCR part, other is the first term, and the third part is the second term. Okay, three brackets required. Now the NCR part, any value is known here, 7. So we can write here 7. Okay. The first term is x by a, so write here x by a. Second term is a by x square, so write a by x square. Now we have to think what power should we write here in the first and second terms, so that after simplifying we should get x raised to the power 4 in the numerator. So if we put 6 there and here 1, because sum of the power should be 7 only. So 6 plus 1, 7. Right? Now, one kept here, we have to keep here also 1. 7c1. Whatever comes at the last bracket power, that power comes here in the NCR part as R. Okay. Now we'll simplify this. So we get 7 into x to the power 6 divided by a to the power 6 into a by x square. Okay, and if you simplify this, we get 7 by a power 5 x raised to the power 4. Okay? This is the term. Now the other term we have to find term in x. So let us find. Again, we need to put three brackets here. Okay, first part will again have 7 here, r value not known, and first term is x by a, so right here x by a. Second term is a by x square, so a by x square. Now we have to find term in x. So term in x, so what we can put the powers? You can use trial and error method. If I put 5 here and here 2, so 2 to the 4, x raised to the power 4 comes in the denominator, and in the numerator x power 5 comes. So 5 minus 4, that gives us x power 1, that is x will be left in the numerator. Okay, so 5 and 2 will work. So 2 at the last bracket, so 2 comes here. Okay, now let us simplify this. 7c2 we get 21. Then x power 5 divided by a power 5 into a square divided by x raised to the power 4. And if you simplify this, we get 21 by a cube x. Yeah. So we got terms in x4 and terms in x. Now we can find coefficient and compare. So coefficient will be this here, and this is other coefficient of x, right? So we'll write them as fraction, and that equal to 3. That is what is the question given. So let me write. Now 7 by a to the power 5 divided by 21 divided by a cube is equal to 3. Two fractions we have. We are dividing, so let us write as a multiplication. So we can write 7 by a to the power 5. When you then it becomes a by a cube by 21. When you are changing division into multiplication, we have to write the reciprocal of the second fraction. So for 21 by AQ, I wrote AQ by 21, and that is equal to 3. Let us simplify this now. Here 7 3 are 21. So we, and here AQ, this is A square, right? So we can write 1 by 3A square is equal to 3. So that gives us 9A square is equal to 1. So A square equal to 1 divided by 9, and this implies that A equal to plus minus 1 by 3. Square root of 1 by 9, we will write both positive and negative square root. So we have to write, find the possible values of the constant A. So we got possible values are plus 1 by 3 minus 1 by 3. Okay. Question number 7. By first obtaining a quadratic equation in cos theta, solve the equation tan theta into sin theta equal to 1. So let's start. We have tan theta into sin theta equal to 1. Let me write tan theta into sin theta equal to 1. Tan theta can be written as sin theta by cos theta. And sin theta into sin theta is equal to 1. So this can be written as, when you simplify, we get sin square theta is equal to cos theta. This can be written as sin square theta minus cos theta equal to 0. Now we want quadratic in terms of cos theta. So what we can do from the Pythagorean theorem, we can write sin square theta equal to, we know sin square theta plus cos square theta is equal to 1, and this gives us sin square theta equal to 1 minus cos square theta. So we will substitute there. Let me substitute 1 minus cos square theta here. Then minus cos theta as it is equal to 0. Let's arrange them. We got minus cos square theta minus cos theta plus 1 equal to 0. First term generally should be positive. So to make the first term positive, what I am going to do, I am going to multiply the whole equation by minus 1. Okay, and once you multiply the equation by minus 1, term, each term's sign will be opposite. So this is negative, so this becomes positive. So cos square theta, then minus minus again plus, so this also becomes positive, and plus minus minus, so minus 1 equal to 0. This is the equation we got, and as we can observe that this cannot be factorized, so we need to use quadratic formula. Okay, so let us solve by using quadratic formula. We will write, therefore cos theta is equal to, now here A is 1, B is also 1, C equal to minus 1, right? So let's substitute minus B. So minus 1 minus 1 plus minus root under B square, so 1 square minus 4A. A is 1, C is minus 1, so minus 1 and divide by 2A. 2A, 2 into 1, 2 only. So we can write cos theta is equal to minus 1 plus minus root under 5 by 2. I hope this is up to here clear. Okay. Now we can write them separately. There are two values, one with positive sign, other with minus sign between the terms, minus 1 and plus 45. So let us write them separately. We can write therefore cos theta equal to minus 1 plus root 5 by 2, and the other value will be writing with minus sign, so minus 1 minus root 5 divided by 2. As you can see here, the second part, minus 1 minus root 5 divided by 2, that will be giving us more than minus 1. So cos theta cannot be more than minus 1. So it will be giving us no solution from here. Okay. So we need to solve only the left hand side part. So if you put theta cos inverse minus 1 plus root 5 by 2, theta equal to, we get 51.8 degree. Okay, 51.8 degree. Now one value we got in the range 0 to 360. We have to find the all the possible values. So other value will be found by subtracting from 360. So 360 minus 51.8, and that is 308.2. So why it is so? Why need to subtract? Let us see. Let us draw a cast diagram. And we got first angle for cos positive. Cos is positive in the first quadrant and the fourth quadrant. So this is your principal angle 51.8. Then other part will be drawing in fourth quadrant because cos is positive in this quadrant also. So this is also the same value. So we need to find the angles. One is this. This is 51.8. Other angle will be from here to here. Anti-clockwise you find the positive angle. Okay. So that is why we need to subtract 51.8 from 360. 308.2 degree. So theta finally we need to write 51.8 degree, comma 308.2 degree. Final answer you must write at the end clearly. Part B. Part B is show that tan theta by sin theta minus sin theta by tan theta equal to tan theta into sin theta. So we will start with left hand side. So let's take LHS. We have tan theta by sin theta minus sin theta by tan theta. Okay. Now tan theta, we know that we can write tan theta equal to sin theta by cos theta. So let us write sin theta by cos theta. This I wrote for tan theta. Sin theta in the denominator already there. So that we have to bring down, minus sin theta by sin theta by cos theta. That cos theta. So here cos theta. Now what we can do is dividing by cos theta will go up in the numerator, and we can write like this. That cos theta comes here. Okay. Now next step, sin theta by cos theta sin theta minus sin theta cos theta divided by sin theta. Now we can write this as a single fraction. So we'll do cross multiply. Cross multiply, I mean to say, we can go like this. Okay. So sin theta into sin theta becomes sin square theta minus sin theta cos theta into cos theta sin theta. So sin theta becomes sin square theta, and cos theta becomes cos square theta. And denominator will be multiplied together. So sin square theta cos theta. Okay. Next, we can take sin square theta common in the numerator. So let's take common. Sin square theta into 1 minus cos square theta we can write here, divided by sin square theta into cos theta. Now this sin square theta cancelled out. So we are left with 1 minus cos square theta divided by cos theta. And 1 minus cos square theta is sin square theta divided by cos theta. So we can write here sin theta into sin theta. For sin square theta, we can write sin theta into sin theta. Cos theta, I can write over here. Now, we can write sin theta by cos theta as tan theta, and sin theta as it is. And that is equal to RHS. So hence proved. Okay. Now, question number 8. Here it says the diagram shows triangle ABC in which angle B is a right angle. The length of AB is 8 centimeter and the length of BC is 4 centimeter. The point D on AB is such that AD equal to 5 centimeter. The sector DAC is part of a circle with center D. So find the perimeter of the shaded region. Shaded region we can see here. This is a sector, part of a sector, right? And we have to find the perimeter. So for finding the perimeter, we need length AC, I mean to say this, and we need this arc length. So calculate the arc length. We need angle theta D here, angle ADC required. Okay. Now to find that angle, let us see what we can do. Suppose this is theta. Now what we can do here, we can find angle BCD. BCD means this angle. Suppose this is theta 1. Okay. In this right angle triangle, easily we can apply tan theta and find the angle theta 1. And whatever angle theta 1 we get, we subtract from pi to get the theta, right? We have to do in radian, that's why we will subtract from pi. So let's do. Let's find tan theta 1. So tan theta 1 equal to, we know that opposite by adjacent, so 4 by 3. This implies that theta 1 equal to tan inverse 4 by 3. And if you find the value, we get 0.9272. We should write minimum 4 to 5 SF because this is not the final answer. We have to use this answer in the next part. So we should not write in 3 SF here. Okay. So 9272, suppose I am taking one more digit, 9. So this is the theta 1. Now we can find theta. Therefore, angle theta pi minus 0.92729, and that gives us 2.214302. This is our theta. Okay. Now to find, we need to find the arc length. For arc length, what is the formula? Arc length AC we can find by using the formula r theta. R is how much? It's given here. AD, which is 5 centimeters. So this is the radius. Okay. So let's find arc AC. Arc AC is found by r theta. R is 5 and theta is 2.214.214302. So that is 11.072 centimeters. Okay. Now we need this AC, diagonal AC of the right angle triangle. So side AC, how to find? We can apply the Pythagoras theorem. AC root under 8 square plus 4 square, that is equal to 8.94 centimeter. Okay. Now we need to find the perimeter. So perimeter equal to arc length AC, perimeter of the shaded part. Okay. So arc AC plus AC. So arc AC is 11.702 plus 8.94 is the AC. 94. Now That gives us 20.0 centimeter in 3 SF. 0, 1, 2 coming. So 3 SF 20.0 centimeter. Okay. Next part. Find the area of the shaded region. So to find the area of the shaded region, let us see the diagram. We can find the area of the sector. I mean to say this whole thing. Let me show you here. Okay. So area of the sector we can find, and then we can subtract the area of uh, this triangle. So that will give us area of the segment. Shaded part is the segment. Okay. Let's do. So area of triangle ACD. Half into 8 into 4 minus half into 4 into 3. Why it is so? Half into 8 into 4. What we are doing? Bigger right angle triangle means triangle ABC, area of triangle ABC minus area of triangle ADC, sorry, BCD. Okay. So we are subtracting, that will give us the area of that triangle. So this gives us 16 minus 6, that is equal to 10 centimeter square. Next, area of sector ACD. Sector ACD is equal to half r square theta, that is the formula. So half r is 5, so 5 square, and theta we have got 2.214302. So if you calculate this, we get 17 point, sorry, 27 point, not 17, 27.678 678,775 centimeter square. So let us find the shaded area. Shaded area equal to 27.678775 minus 10, that is equal to 3 SF. It will be 27.7 centimeter square. 17, not 27. So sorry for the mistake. 17.7 centimeter square. Okay. Question number 9. The function f is defined by fx equal to minus 3x square plus 2 for x less than equal to minus 1. So domain for this function is less than equal to minus 1. So we have to find the range. So we'll find f minus 1. Let's find f minus 1, that is minus 3 into minus 1 square plus 2, and if you calculate we get minus 1. Now if you find minus 2, you get minus 3 into minus 2 square plus 2, that is if you calculate, so 4 minus minus 12 plus 2 minus 10. So if we observe the pattern, highest value will be getting minus 1, other values, all the value less of x less than equal to minus 1 will be getting smaller than 1. So what we have to do, range becomes fx less than equal to minus 1. This is our range. Okay. Now part B, find an expression for f inverse x. So to find inverse, first let us write in fx, we place of fx we'll write y equal to, we have minus 3x square plus 2. Now swap x and y. Swap x and y means in place of x write y, in place of y write x. So here comes x and here comes 3y square plus 2. So we get x minus 2 equal to minus 3y square. Now y square can be written as x minus 2 by minus 3. Denominator should not be negative, so we have to make it positive. So what we will do, multiply top and bottom by minus 1, so that becomes 2 minus x by 3. Okay. Now we need y. So y equal to, we'll get 2 minus x by 3 square root, but there are two square roots, one positive, another negative. Now how to decide which sign we have to take here? So go to the domain given. Domain is x less than equal to minus 1. So that means y is less than equal to minus 1. Okay. So y less than minus 1, less than equal to minus 1 means y going to be negative for the domain. So this is minus. And final answer we'll write in terms of f inverse x. So replace y as f inverse x minus 2 minus x by 3. So this is our answer. Let's go to the next part. The function g is defined by gx equal to minus x square minus 1 for x less than equal to minus 1. Solve the equation f gx minus gfx plus 8 equal to 0. So in this question, you need to find f gx, then gfx, and we'll substitute those values here in the equation to form an equation in x, and then solve for x and y. So we'll be solving for x. So before that we have to find fgx and gfx. Let us find fgx. We have fx here. Let me write fx from here. Minus 3x square plus 2. And gx is minus x square minus 1. Okay. Now let us find fgx. So f gx, that means f, we have put gx in fx. Gx is minus x square minus 1. Okay. So we have to put in place of x, we have to put minus x square minus 1 in function f. So let's put, if we are substituting, we get minus 3, and for x we'll be writing minus x square minus 1, and there is a square here, so put a square, right? Then plus 2, so plus. Now what I can do here is simplification. So write minus 3, and here both are negative, so we can make both positive by squaring, so that becomes x square plus 1 whole square, because minus sign, if you take common and square it, becomes plus. So plus 2. So we are having f gx equal to minus 3x square plus 1 whole square plus 2. Okay. Now let's find g of x. This time we have to put fx into gx. So g fx is minus 3x square plus 2. So right here minus 3x square plus 2. Now next we have to substitute into g. So let's substitute minus 3x square plus 2 whole square minus 1. Okay, now let us expand this. Or you can substitute the value. Let us put, then we will expand this. Now let us put the value in the equation. So we have fgx. Fgx is minus 3 into x square plus 1 whole square plus 2. Then we have minus gfx. So this minus and this minus becomes plus. So we write plus here, and we write minus 3x square plus 2 whole square, and this minus also becomes plus. Plus 1 plus 8 equal to 0. Okay. Now let us simplify. So minus 3, it comes here x power 4 plus 2x square plus 1 plus 2 plus this minus 3x square. If you are squaring, we get 9x square minus 12x square, sorry, x4, 12x square plus 4 plus 9. 8 plus 1, 9. That is equal to 0. Now let us, if you simplify this, we get 6x4 minus 18x square plus 12 equal to 0. By combining like terms, we simplified and we got this. Now see, we got equation in terms of x4. We can make it, see, all the three terms are divided by 6. Let us simplify further. So we get x to the power 4 minus 3x square plus 2 equal to 0. Now let us make it quadratic. So let x square equal to y. So we can write y square minus 3y plus 2 equal to 0. Then we can factorize this. So we will get y minus 2 into y minus 1 is equal to 0. Next, so with this gives us y equal to 2 or y equal to 1. So y equal to 2, what does it mean? Or y you have taken x square, so x square equal to 2. So x equal to plus minus root. Here y equal x square equal to 1. So x equal to plus minus 1. So these are the values we got, but we have to see in the question it says x should be less than equal to minus 1. So we have to take only negative values. Okay. So final answer we will write like this. Therefore, x equal to minus root 2 and x equal to minus 1. Okay. Let's go to the next part. Next question. Question number 10. At the point 4 minus 1 on a curve, the gradient of the curve is minus 3 by 2. It is given that dy by dx equal to x raised to the power minus half plus k, where k is a constant. Show that k equal to minus 2. So, what we can do, dy by dx, given here minus 3 by 2. Gradient is minus 3 by 2 means at x equal to 4, dy by dx value is minus 3 by 2. Okay. This is given here x equal to 4. This is the gradient given and this is dy by dx given. So we'll write dy by dx is equal to, we have x raised to the power minus half plus k. The value dy by dx given here is minus 3 by 2 gradient, right? Minus 3 by 2. And that is x value is 4. 4 to the power minus half plus k. This gives us minus 3 by 2 equal to 1 by 2 plus k. So k equal to minus 3 by 2 minus 1 by 2, that gives us minus 4 by 2, that is equal to minus 2. We have shown. When it says show that, that means you have to show all the steps. How did you find? Okay. Okay. Now let's go to the next part. Find the equation of the curve. So whenever you have to find the equation of the curve, dy by dx will be given and we need to integrate that. Then we need to find value of c and finally we will substitute. Okay, this is the whole procedure. So dy by dx, let us write dy by dx is equal to, we have x raised to the power minus half. Now k value we have got minus 2, so we'll use minus 2 here. Okay. So now integrate both sides. So we get y is equal to, now integration of x to the power minus half is x to the power half divided by half, and minus 2 is minus 2x, constant of integration here. So y equal to, we can write, if you simplify, 2 goes up, 2x to the power half minus 2x plus c. Now we need to find value of c, constant of integration. For that they have given one point here, 4 minus 1. Okay, so we'll substitute x equal to 4, y equal to minus 1. So let's substitute minus 1, 2 into 4 to the power half minus 2 into 4 plus minus 1 equal to 4 to the power half is 2, 2 to the 4, and minus 2 into 4 minus 8 plus c. So minus 1 equal to minus 4 plus c. So c equal to 4 minus 1. C equal to 3. So c equal to 3. Now we will substitute in the integration. Here we have integrated. So let's substitute y equal to 2x to the power half minus 2x plus 3. So this is your answer. Okay, that also can be written as root. Let me write in that form also. 2 root x minus 2x plus 3. We can write in this form also. So either one is correct. This is the curve, equation of the curve. Part C. Find the coordinates of the stationary point. So whenever you have question like this where you have to find the coordinate of the stationary point, means we need to write dy by dx equal to 0 and solve for x. Okay. So let us take dy by dx. So it will be dy by dx equal to 0. Okay. Now dy by dx is x raised to the power minus half minus 2 equal to 0. So let's send this x to power minus half becomes 1 by root x, we can write, and minus 2 shifting to the other side becomes 2. So now if you square, we get 1 by x equal to 4. So this implies that x equal to 1 by 4. By squaring both sides, we get 1 by x equal to 4. Okay. I'm writing here so that you will understand. Square both sides. Why a square? Because we have a square root sign. So we need to get rid of square root. Okay. So x equal to 4. Now we need to find y also because it says coordinates. So means x and y both we have to find. So how to find this? Y equal to, put this x equal to 1 by 4 in the equation of the curve. Equation of, if your curve you are putting 1 by 4, we get, let me see the equation of the curve. We have 2 root x. So 2 root x minus 2x plus 3. Let us put the value 2 into root 1 by 4 minus 2 into 1 by 4 1 by 4 plus 3, and that is equal to 2 into 1 by 2 minus, if you simplify this, we get 1 by 2 plus 3, and if you simplify this, we get 4 minus half, that is 3 and half, that is 7 by 2. So coordinates, let us write the final answer here, is equal to 1 by 4 and 7 by 2. Okay. Done. Now it says determine the nature of the stationary point. So to determine the nature of the stationary point, what you can do, from dy by dx, we can find d2y by dx2, second derivative, and we will see whether it is less than 0 or greater than 0. Okay. So let's write here dy by dx. We have x to the power minus half minus 2. So this also can be written as, let us find d2y by dx2. So d2y by dx2 is minus half comes before, and then x to the power minus 3 by 2 minus 1 by 2. If you subtract 1, becomes minus 3 by 2. For minus 2, it becomes 0, so no need to write. Okay. Now, as you can see here, this is negative term. For any value of x, d2y by dx2 always going to be less than 0. Okay. So what does it mean? It's a maximum point. Hence, maximum. Okay. So done. Now the last question. It says the diagram shows the curve with equation x equal to y square plus 1. The point A 5, 2 and B 2 minus 1 lie on the curve. Find an equation of the line AB. You can see here we have point A and point B. 2 points are given. From the 2 points we can write equation of a line. So how to write? We need gradient. So first we will find the gradient. Okay, so M. We know the formula, y2 minus y1 divided by x2 minus x1. So let's take 2 minus minus 1 divided by 5 minus 2. And if you simplify, this gives us 3 by 3, that is equal to 1. So we got M equal to 1. Now we know y minus y1 equal to M into x minus x1. If one point and gradient given, we can use this formula for finding the equation. So any one point can be taken as x1 and y1, either A or B. There is no hard and fast rule you have to take A or you have to take B. We can take either one. Okay. So I'll substitute in this A, value of M. So y minus 2 equal to M is 1, so put 1, x minus x1, that is 5. So we got y minus 2 equal to x minus 5, and if you simplify, we get y equal to x minus 3 in mx plus c form. It is not mentioned here which form, so we can write in any form. So y equal to x minus 3. This is the answer. Next, find the volume of the revolution when the region between the curve and the line AB is rotated through 360 degree about the y-axis. About the y-axis, keep in mind. So, see, if we are rotating this about the y-axis, this is then this line AB is the outer curve or outer line, and curve part is the inner one. Okay, so we'll find first using the equation for line volume 1 and then volume 2 for the curve, and we are rotating by about the y-axis. Okay, so let's see. We know that v equal to pi a b x square dy. This is the formula when you are rotating the shape about y-axis. Okay, so let's find v1. So we have pi, or curve equation is y square plus 1. Look at this given here, x equal to y square plus 1. So y square plus 1 whole square dy. Okay, now limits will be -1 to 2. You can see here y coordinate -1 and here 2. So limit will be -1 to 2. Next, -1 to 2. Now y square plus 1 whole square will expand it. So we get y power 4 plus 2y square plus 1 and then dy. Now we can integrate this. Y4 becomes y5 by 5 plus 2y square. So 2y cube by 3. 2y cube by 3 plus 1. 1 is y. So here, and limits are -1 and 2. Now pi as it is. Let us substitute the limit. So first one, if you are substituting 2, we get 32 by 5 plus 16 by 3 plus 2. And now minus, put the limit -1. So we get -1 by 5 minus 2 by 3 and -1. Now if you simplify, we get pi 206 by 15 plus 28 by 15. That is equal to pi, and let me write here. If you add this, we get 234 by 15. 234 by 15 pi. And if you simplify this, we get 78 by 5 pi. Okay, this is V1. Let us find V2 using the equation of the straight line AB. So here V2 is equal to pi, limits will be same, minus 1 to 2, and equation is now y plus 3 whole square dy. In the first part we have found the equation of the line, so using from there, see, we have here y equal to x minus 3, so x equal to y plus 3. Okay, that's why y plus 3 here. So let us expand the bracket now. Minus 1 to y square plus 6y plus 9 dy. Pi. Now let us integrate this. So y square becomes y cube by 3 plus 6y square by 2, that is 3y square plus 9y minus 1 to 2. Now we'll put the limits. So pi eight by 3 plus 12 while putting value of 2. So 12 plus 18. Okay. Then now substitute minus 1 for y. So we get minus 1 by 3 plus 3 minus 9, close the bracket. So we get pi times 98 by 3 plus 19 by 3. This equal to 117 by 3 pi. This is our V2. Now we have to find the volume. So V equal to V2 minus V1, because V2 line is outer one. That's why V2 minus V1. And if you see, okay, then this is 39 pi coming, right? 39 pi. So we can write here 39 pi minus 78 by 5 pi, and if you simplify this, we get 117 by 5. So this is the volume. We should write here units cube. Okay, so that was the final question. I hope you enjoyed this video. Please don't forget to share, like and comment on the video. And if you have not subscribed the channel yet, please hit the subscribe button. Thank you.